Hi everyone. In this video we're going to talk about installing the Anaconda Python distribution, which will allow us to perform scientific calculations and plotting through Python. The goal of this video and the series is to introduce you, the viewer, to the fundamentals of scientific programming through Python. Now, I don't expect you to have any experience with Python or programming as it is. The goal of this series is going to be able to introduce you to topics in programming through applied examples. So if you don't have any programming experience and you want to learn, this is a good way for you to start. So to start, if you're using Python, you should know that Python is a general purpose programming language that people use for web development, for app development, and for scientific computing. Although most computers nowadays have, or I should say most Unix builds of computers nowadays have Python pre-installed, if you're running Windows, you will want to make sure you have Python 3 installed. Now, the first step is to install the Anaconda distribution. If you don't have it already installed, which I'm assuming you don't, you can go to anaconda.com/download, and then you can select your installer. We're going to be using the Python 3.6 version. You can click download, and as you wait for the computer to respond, you'll see that it props you up with an option to have a cheat sheet, which I'm going to say no thanks to. And then as you saw hidden over in this window, we have the option to download. So I already have this downloaded, so I'm not going to download it, but you can follow the step-by-step instructions. Okay, so what we're going to be using to program is going to be the Jupyter Notebook interface. Now you can write strict Python programmings, which we'll discuss in later videos, but I prefer to use the IPython, or nowadays known as the Jupyter Notebook, because it allows an interactive environment that allows you to plot things, see results quickly within a cell table, along with to call other programming languages such as JavaScript and shell scripting. But for us, it's going to be a really accessible way to start getting a handle on data. Now, I should say that if you're using Windows and you install it, you can find it under your applications just by clicking on Jupyter Notebook. What we're going to be doing on Macs and Linux machines is you're going to go to your terminal. And again, I'm not expecting you to have any terminal experience. So we're going to click on it. And I'm going to type in the command Jupyter Notebook. And this is going to introduce a whole Jupyter Notebook built into your web browser. Now, this does not require you to be on the internet. It runs locally on your machine, so you don't have to worry about being connected. It will just populate automatically in your browser. Okay, so here we see the directory that we're going to be storing stuff in. Right now it's just my desktop. We'll talk about changing directories and other things like that in later videos, but let's get started right in. So we're going to say new, and we're going to select a new Python notebook. And the first thing we're going to do is introduce the idea of a module. Now, Python is a base programming language that has lots of add-ons, including NumPy and Matplotlib, along with a whole bunch of other applications for web development and data science and whatnot. So we have to realize that if I were just to call certain plotting commands, let's say plt.plot, we're not going to have any response because it's not native to Python. So what we need to do is we need to import certain packages, and we're going to start by importing NumPy, which is a numerical Python package built within Anaconda that allows us to perform linear algebra calculations, and we're going to import this as NP. Now, this is telling the Python to import this package, And because we're going to be referring to it in a lot of subsequent videos and throughout our program when we call functions that belong to numerical Python, we're going to be calling those functions from NumPy. And because it's going to be so repetitive, we don't want to write NumPy out all of the time. So we're going to say import NumPy as NP. Similarly, if we want to plot things, we're going to use the command import matplotlib.pyplot as PLT. And if we're using the Jupyter Notebook, we're going to say matplotlib inline. And I'm going to click Shift Enter, and it's going to process that cell and run that command. Now, we're not going to be really using anything in this tutorial based on NumPy and matplotlib.pyplot. I'll show you a little bit about how to use them, but those are topics of subsequent videos that you can see. So the first idea we need to introduce is the idea of a variable. Now, in math class, you're probably used to hearing, solve for x or solve for this unknown quantity, which we all know is a variable. Mathematically speaking, a variable is just a symbolic representation of some unknown quantity. However, a variable within a computer is a much broader sense. So if I wanted to say, plt.plot x and shift enter, it's going to yell at me. Specifically, we see that x is not defined. So we need to develop a way of thinking that will allow us to successfully communicate our thoughts to the computer. And we do that by explicitly stating variable names. Now, the first variable name we're going to introduce, or the first variable we're going to introduce, is that of an integer. Now, an integer is just a number, and we can store a variable as a number by saying x is equal to 1. Now, we see that that's committed to memory. Let's say we have another variable y is equal to 5. Shift enter. Now that variable is committed to memory as well. Now, if I wanted to display say this variable, we can say print. Now, print is not going to call a printer or anything like that. It's going to tell the screen to print something. So in this case, we can print x and press shift and enter, and we see that it produces the output of 1. Similarly, if I wanted to do the operation x plus y, it will print the result. Now, it should be noted that this is not storing anything, so we have not stored x plus y in the computer. It just ran this operation. If we wanted to store this operation, say in a new variable z, we could say z is equal to x plus y, and now z is stored. If we wanted to see the value of z, we could say print z, and we get, of course, 6. Another type of variable that we're going to be using is the float. Now, a float is just a floating point number or a decimal. We're not going to get into the specifics on why there's different designations for the computer between an integer and a floating point number, but there are reasons. So a simple floating number, let's say, would be car is equal to 4.768. Now we see that we can call a variable anything we want. We're not just limited to x, y, and z. However, we should define variable names for something that's recognizable. And also we should say that we couldn't just say 8 is equal to something, a numerical value. Variables tend to be stored using letters. And again, we want to designate an intelligent way of storing variables. So if I had data, I might want to call it data, or the type of data I'm using. For example, if I'm dealing with drop times of an object or something like this. So again, if I want to store this variable car, as 4.768. I can do Shift Enter, it's stored, and print car. We're going to see that if we want to call certain numerical numbers, transcendental numbers such as pi or the value e, we have to call those numbers through NumPy because they are not specifically built into Python. So for example, if I wanted to say new number is equal to pi, I have an error because Python doesn't know what to do. So we need to tell it to go to the numerical Python package and call that constant pi. So in this case, we can say new number is np because we want to designate that we're going to be looking in the NumPy package, followed by a period, followed by what we want to call from that package, which in this case is pi. So if I do Shift Enter, we see that it accepted the variable, and if I wanted to print that value, I could do print new number, and there I have it as pi. If I wanted to, for some reason, determine the type of the variable, I could say print, and then I could use the function type, new number, and we see that this belongs to the floating point numbers class. We're not going to worry about what a class is right now. Just think of it as a type of variable. So, unlike mathematical variables, which generally we found numbers with, computers store information in terms of variables. So we could say name is equal to Sally. Now this variable is what we call a string. A string is just a set of characters to be interpreted by the computer as a word, and they're designated in Python either by single quotation numbers or double quotes. So I could say the name Sally. I don't have to create a new cell each time I run a command. I can run multiple commands in the same cell, and I can say print name followed by print type of name, and we see the computer name prints Sally, and it belongs to the class string. The next type of data, or rather the next type of variable we're going to be using a lot of is the array. Now, an array is just a way of storing information. We can do that by saying, calling the variable, say list of numbers, and we want to specify it as an array, and we can do this by np.array telling the computer we're going to call this NumPy package and call the function array, which creates an array out of something, followed by square brackets, and say the list of numbers we want. Say 1, 2, 3, 4. Now we're going to talk about arrays in detail in subsequent videos, but here again I'm just showing you the different variable types. I can say print list of numbers and print type of list of numbers. And here I go. I have my list of numbers, 1, 2, 3, 4, and it belongs to the np.nd array class. So let's just recap what we learned in this video. We learned how to introduce variables. Specifically, there's a couple different types of variables that we learned about, namely integers, floats, strings, and arrays. We also learned the basics of displaying information through Python through the print function, which again displays information to the screen. And lastly, we introduced the type function, which tells us the type of variable that we're dealing with. Now, in future videos, we're going to go into more detail about these types of variables, specifically in applications. But again, this video was just a brief introduction to how to think like a computer scientist. If you like this video, please check out other videos in the series, and thank you for watching.